Good morning, class, and welcome to Lesson 5.2.4. What does a log graph look like? Your objective is going to be able to graph logarithmic functions. Now, recall, how do graphs, tables, domain, and range of inverse functions compare? When we start thinking about the domain and range of inverse functions, we know that they are inverse functions because we have swapped the x and y, and one graph is a reflection of the other over the line y equaling x. So if we take those things into account and we have a function f of x, it has a specific domain. Maybe the domain of f of x happens to be x equals all real numbers. And the range for this particular function is that y is greater than or equal to 0. Then the inverse function has the domain and range being swapped with each other. So then the domain of the inverse happens to be x greater than or equal to 0, and the range for the inverse happens to be y equaling all real numbers. The tables, if this is f of x, and here's the x, and here's the y, here's our values over here, and let's just use a different color, and here's our values for y, then the inverse f of a negative x, the domain, or our x values and y values, are swapped. These input values for f of x become the output values for the inverse, and our output values for f of x become the input values for the inverse. Now, there are some restrictions that we have to be aware of, and we've covered those in some of the previous lessons back in Term 3. So let's take a look at this with logarithms. This lesson is going to investigate graphs of y equaling log base b of x. Since f of x equals log of x is a parent function, it is important that you can visualize and transform its graph as well as sketch graphs in different bases. Graphing the logarithmic function. Sakura needs to graph y equaling log of x. Now remember, this log of x happens to have a base 10, so she's really thinking of y equaling log base 10 of x. Write an equivalent exponential equation for y equaling log base 10 of x. Well, an equivalent exponential equation is going to be 10 to the x equals y. These are inverse functions. Logarithms and exponents are related. But how? What is the inverse equation of y equaling 10 to the x? Well, we just answered that. The inverse equation is y equaling the log base 10 of x. So we want to make a table and a sketch of y equaling 10 to the x and y equaling the log of x. Now I'm going to take and pause this and fill in our tables, our domain, and the graphs, and then we'll come back and take a look at it. Okay, so welcome back. Now what I've done is I've built the table for y equaling 10 to the x. Here are our input values, so take a minute to study those. If we plug 2 in there, 10 squared is 100. If I plug 1 in there, 10 to the first is 10. If I plug 0 in there, 10 to the 0 is 1. If I plug a negative 1 in there, 10 to the negative 1 is 1/10. And if I plug a negative 2 in there, 10 to the negative 2 is 1/100th. If I graph that, I get this blue graph for my exponential curve. And there's a horizontal asymptote on the x-axis. And so my domain is x is equal to all reals, and y has to be greater than or equal to 0. Now for the log of x, in order to graph the log of x, what I'm going to do is swap my domain and range. That means in my table, the x values over here for 10x become the y values for the log base 10 of x. And the y values for 10 to the x become the x values. And down here, our domain and range have traded places. So if we think about it, log base 10, and my input value log base 10 of this 10 has to equal, well, that's going to be 10 to what power gives me 10, and that's 1. That's where this 1 comes from. If I take a look at this, log base 10 of 1 equals, well, what I'm thinking is 10 to what power gives me 1? Well, 10 to the 0. That's where this pair of points comes from. So we can go through and try to evaluate for all of our x values to build this table for log of x, or just take your 10 to the x table and flip-flop your x's and y's. So to graph this now, all I'm doing is taking either my graph that I see in blue, or I'm taking this table that I created by swapping the x's and y's from y equaling 10 to the x. So now I'm going to plot my locator point, which is 1, 0, that's right there, and 10, 1, that's right there. 102 takes me off the graph, and 1/10 negative 1, that's going to be right in here, really tight, and my graph is going to look something like this, and that horizontal asymptote that we had on the x-axis now becomes a vertical asymptote on the y-axis. So here are your steps to graphing a log function with a transformation, because that's what we're going to work on now. So if I just have a basic equation of log base b of x equaling y, and the inverse to that then is b to the x equaling y, what we basically did on the previous page, and we'll be doing this coming up here with the next few problems, is build a table for that exponential function. Then convert that table to a table for the log base b of x equaling y by switching your x and y values. Then apply your transformation to the problem. Here's what that would look like. Let's take the equation y equaling 5 times the log base 3 of x. And what I want to start out with is identifying my base equation. Here's that base equation, just log base 3 of x. And I'm going to write that as y equaling log base 3 of x. Its inverse then has to be y equaling 3 to the x. Let's build a table for y equaling 3 to the x, y. Let's go -2, -1, 0, 1, 2. And if I plug 0 in there, 3 to the 0 is 1. 3 to the first power is 3. 3 squared is 9. Going the other direction with my negative x values, 3 to the -1 is 1/3. 3 to the negative 2 is 1/9. And now I'm going to take that table and convert it into a table for log base 3 of x by switching my x and y values. So all of these output values for 3 to the x become my input values, 1/9, 1/3, 1, 3, and 9. All of the input values for 3 to the x become the output values, -2, -1, 0, 1, and 2. My domain over here is x equaling all reals. My range is y greater than 0. And now those will switch for the log base 3 of x. The domain is x greater than 0. My range is y equaling all reals. So now I want to graph the log of 3 to the x, and that's going to have a vertical asymptote on the y-axis. My locator point is 1, 0. Then I have some other points, 3, 1, and 9, 2. Going down here, I've got 1/3, -1. And I don't know if I can get the other one on there. So my graph looks something like that for y equaling log base 3 of x. But what I really want to create is 5 times the log base 3 of x. That means it's going to become 5 times taller, or a vertical stretch by a factor of 5. That means all of these output values for log base 3 of x have to become 5 times taller. So this table, I'm going to write it sideways, x and y. X isn't going to change. We've got 1/9, 1/3, 1, 3, and 9. The output values have to be multiplied by 5. So that's going to become -2 times 5 is a -10, a -1 times 5 is a -5, 0 times 5 is still 0. An output value of 1 times 5 is 5, and 2 times 5 is 10. And now I'm going to graph this, starting with my locator point, and then I have 3, 5, so 3 over, and now 5 up, and then 9 over, and 10 up. Going the other direction, x is 1/3, -5. Oops, it's a little bit right there. So here's what this graph is now going to look like. Let's go try another one with a different transformation. Y equaling log base 0.5, or 1/2, of x minus 2. My parent function or base equation is y equaling log base 1/2 of x. So let's write y equaling the log base of 1/2 of x. Its inverse then has to be y equaling 1/2 to the x. Let's build this table. X, y, -2, -1, 0, 1, 2, and plug these values in for x. 1/2 to the 0 is 1. 1/2 to the 1 is 1/2. 1/2 squared is 1/4. Now going the other direction, 1/2 raised to a -1 is going to give me 2. 1/2 raised to the -2 is 4. Now use that table to build the table for log base 0.5 of x. Here's x, here's y. My y values over here become the x values for the log base 0.5 of x. So 4, 2, 1, 1/2, and 1/4. The x values for my exponential function become my y values for my logarithmic function. -2, -1, 0, 1, and 2. I'm not going to get into the domain and range for this particular problem. Now let's graph y equaling the log of 0.5x. It's going to have a vertical asymptote on the y-axis. Now let's plot our points. 4, -2. So that's going to be 4 over and 2 down. 2, -1 is 2 over, 1 down. 1, 0 is our locator point. 1/2 +1. And 1/4 +2. And so this graph looks like that. Now apply your transformation. Our transformation is a -2, which means we are going to have a vertical shift down 2. So let's build a table for that. X and y. X values stay the same. 4, 2, 1, 1/2, 1/4. And my y values have to go down 2. So I'm going to take each one of these, and I'm going to minus 2. So this becomes -4, -3, -2, -1, and 0. So now let's plot those points. 4, 4, -4, so that's 4 over and 4 down. 2, -3, that's 2 over, 3 down. 1, -2, 1 over, 2 down. 1/2, -1, 1/2 over, 1 down. And 1/4 is 0. That's right there. Here's what my graph would look like. For y equaling the log base 1/2 of x minus 2. I'm going to do one more for you, and then the last two you can work on. This is y equaling the ln of x minus 3. Now this one's going to be a little bit different because we're going to end up with this horizontal shift right in here. So let's just start by identifying that, okay? We have a horizontal shift to the right 3 units. My base function is just the ln of x. So let's write y equaling the ln of x. And its inverse equation is y equaling e to the x. Let's build a table for y equaling e to the x, y, -2, -1, 0, 1, 2, and then find the x values, or excuse me, given those x values, find the y values. And when x is a -2, and I plug in -2 in there, e to the -2 is 0.135, e to the -1 is 0.368, e to the 0 is 1, because anything to the 0 is 1. E to the first power is 2.718, and e squared is 7.389. Take this and build your table for the ln of x. Here's my x, here's my y. These y values for e to the x, or our exponential equation, becomes the input values for the natural log, or our logarithmic equation. So 0.135, 0.368, 1, 2.718, and 7.389. The x values for our exponential equation then become the output values for the logarithmic equation. -2, -1, 0, 1, and 2. Let's graph the ln of x. First thing I want to do is draw in that vertical asymptote, and then plot these points, 0.135, -2, so it's going to be right in there. 0.368, -1, that's right about there. 1, 0, that's our locator point. 2.718, 1, that's right up there. And 7.389, 2 is right up here. And so the graph for the ln of x looks something like that. Now I want to apply this horizontal shift. I want to now graph y equaling the ln of x minus 3. So I'm going to take that graph or table and I'm going to shift it right 2 units. To do that, shift it right 3 units. To do that, add 3 to every x value. So now I have 3.135. Output stays the same. 3.368. Output stays the same. 1 plus 3 is 4. Output stays the same. 2.718 plus 3 is 5.718. Output stays the same. And then 7.389 plus 3 becomes 10.389. Output stays the same. What also shifts is that vertical asymptote. So the vertical asymptote for the ln of x minus 3 has to also be shifted over 3 units. So I'm going to zoom in just a little bit here so I can get this to be specific and right on. 3 units over, there's the vertical asymptote for the ln of x minus 3. Now let's plot these points. 3.135, negative 2. So 3.135, negative 2, it's going to be right in there. 3.368, negative 1 is right in there. 40 is right there. Oops. I have to zoom in. 40. And then 5.718, 1 is right up here. And 10.389, 2 is going to be right up here. And so here's what this graph looks like with a vertical asymptote at x equaling 3. What I would like you to do is try D, y equaling a negative log base 4 of x, and then check your answers. So pause this now, complete it, and then come back and check your answer. Okay, welcome back. You can go through, check your work. I'm not going to go through this individually. One thing that I do want you to focus in on that I have left out a little bit from, or haven't been consistent going through, is finding your vertical asymptote, domain and range for this final function that you're trying to graph. So in part D, y equaling a negative log base 4 of x, your vertical asymptote is still going to be at x equaling 0, and your domain and range is x greater than 0, y equaling all real numbers. Here's our last one, y equaling ln of x plus 4, in parentheses, plus 1. This has 2 transformations. Our base or parent function is going to be the ln of x. Its inverse is y equaling e to the x. So go ahead, pause this, build your table for the y equaling e to the x, then build your table for the ln of x, then apply your 2 transformations and make the graph for y equaling x plus 4, y equaling ln of x plus 4 plus 1. Also, please take time to identify any vertical asymptote, identify the domain, and the range for this transformed function. Okay, welcome back. You can take a look at all the work on the right-hand side, if that's something that we've already done in the past, where we've taken and graphed the ln of x. Now we need to take that table for the ln of x and apply the 2 transformations that we have here, which is a shift of 4 units left and a shift of up 1. Now if we just start thinking about this, the ln of x, it has a vertical asymptote on the y-axis. Well, if I'm going to shift 4 left, that's going to move that vertical asymptote 4 units to the left. And that's what you see here in red right now. This shift of 4 moves that asymptote 4 units left. So my vertical asymptote is at x equaling a negative 4. Now to build the table, all of my x values have to be shifted 4 to the left, which means I'm going to take all of these x values and minus 4, and then all of my y values are going to have to be moved up 1, so plus 1. That gives us the table that you see down here. Plot those points and sketch your graph. What does this do to your domain and range? Well, the domain then starts at that vertical asymptote. It's everything greater than that vertical asymptote. So your domain is going to be x greater than a negative 4. The range is still all reals. hopefully you enjoyed this lesson. This would be definitely a unit to go visit your teacher during office hours, and possibly watch a supplemental video or two. Again, test is coming up on Thursday. You'll be reviewing on Wednesday, and I wish you the best. Have yourself a great week, and more videos next week with Chapter 6.